a brief introduction to the level 3, so to the visceral part of the fascial manipulation. Now try to compare your trunk to this glass. Try to think about as the organs and the viscera that it contains to these candies, like this. Okay, of course they don't fly, they don't move like this inside the trunk, okay? And this is why actually every time you go to the toilet and you push, actually you don't have to take back your liver or your kidneys from the toilet itself, because actually they are supported. They are supported by fascia. It's called peritoneum, and so on. Each organ presents a capsule. There are a lot of visceral fascia inside the body. Now, where did I put my pen? Here. Try to consider the trunk to that kind of glass. If you want to cut it, you're going to see something like this. This is a section, a transverse section of the trunk. You're going to see something similar to a honeycomb. Of course, it's not as simple as this, and it's a big simplification. But still, in every cell of the honeycomb, in every compartment, you're going to find a specific organ. Okay, let's say liver, stomach, intestines, and so on. Okay. Now, these honeycomb, these organs inside the honeycombs actually behave like bees. In order to do their job, to perform their job, actually they need to be able to move inside the compartments. So they need space. And the movements of each organ is called motility and mobility. The motility is the ability to contract, okay, like the heart, like the intestine, okay, so the function of the muscle of the organ itself. The mobility is the ability to move in every direction inside its space. The thing is that not even the honeycomb is flying inside the trunk, but is attached to the border of the trunk to something called prevertebral fascia in the back, which means before the vertebra, and transverse fascia underneath the rectus abdominis and the transverse muscles in the front. Okay, so this is basically the attachment of the peritoneum and all the other visceral fascia. Now the thing is that these two fascias, the transverse and the prevertebral fascia, are attached to the deep fascia of the muscle of the trunk. So basically the latissimus, the pec, the rectus abdominis, so the muscle that you basically find outside. And these are the muscles where we can find the center of fusion and the center of coordination. Each muscle presents its own fascia. So basically there is a direct connection via the fascia from the muscle outside the trunk to the prevertebral or the transverse fascia to the honeycomb. And this fascia can stay wide open just because the tension that they receive from the muscle, which means that each muscle and its center of coordination now is not responsible for the movement of the trunk, but its tension is responsible for the opening in every direction of this honeycomb. Something like this. Okay? And the perfect balance between all these tensors actually is responsible and guaranteed for the correct opening of each single compartment. Now, when we have a densification, that muscle probably is working too much, so it's pulling too much, or is not working at all. And let's say that, for example, the internal rotation of the lumbi is not working. So there's no tension here, There's no tension here. And basically the fascia is just tensed by maybe the lateral motion and the antilateral motion, which means that the fascia collapses on the organ. Instead of being open like this, it collapses on the organs. So it modifies completely the shape of these compartments. And an organ that actually is here, maybe can be just restricted by the fascia. Even if the organ is fine, it's just restricted. So now think about this kind of restriction and let me give you an example. Think about the intestine. Now, the thing is that the food is moving inside the intestine, okay? Call it kaki, call it food, whatever you want. It must go toward the rectus. And there are two kinds of movements, longitudinal and circular. Okay, so this circular movement and this longitudinal movement push forward the food. There are circular muscles and longitudinal muscles in the intestine. Their perfect coordination push forward the food. Now, outside those muscles, there is the fascia. There is their fascia that coordinate also this movement. If the fascia is too tight, think about a tight sock around the intestine. The intestine is able to contract and is not able to relax. That slows down a lot the movement of the food inside the gut. And how do you call when the food is moving slow toward the rectus? Constipation. Exactly. Think about, for example, the bladder. The bladder is like a balloon that fills up with urine. Around this balloon, there is another balloon made of fascia, which is full of mechanical receptors. Something like this. As the urine actually fills in, of course, the balloon increases its size and stretches also the green balloon outside. Just by stretching this green balloon, all these receptors can send to the brain the feedback, the right feedback, and tell the guy, listen, it's time to go to the toilet. Otherwise you're gonna pee in your pants. Okay. So basically these receptors are mechanical receptors activated by the stretching. And when the stretching reaches a specific tension, so when the length of this balloon reaches a specific size, it starts sending the feedback. Exactly like the pacini, the ruffini embedded into the deep fascia. The thing is that if this fascia is too tight, and even when the bladder is empty, there is already tension over the green balloon, you need much less urine to send the feedback. So maybe the guy is waking up 3 times or 4 times every night, and the doctors blame usually the prostate, okay, which is pushing on the bladder, instead of just a matter of acting on these points, regulating the tension that reach the organ from the outside, and then you can restore the normal function of the organ. Now, the thing is that you don't have just to think in terms of points of the trunk and peritoneum, but it's a global technique. And this is the main thing regarding the upper limb and the lower limb. Do you remember the Brooklyn Bridge? Okay, this is the space for the car. Then you have the pylons, the vertical pylons, and you have a cable. And this is the same cable from the beginning to the end of the bridge. Now think about one guy with his hands up here, the shoulders, the back, the butt, the glutes, the feet, the legs, the belly, so it's a thin guy. Okay, and the neck. Now this is the scapular, the shoulder blade, this is the hip, or the hips, These are the hands, the feet, and the belly. This is the fascia of the upper limb connected to the fascia of the trunk, prevertebral and paravertebral and transverse fascia. And this is the fascia of the lower limb. And everything is in connection. Now think about some pendulum. Okay, so the organs are just attached to the fascia in this way. And also to the fascia of the back, like this. Now think about a knee injury or an ACL reconstruction that cause a lot of densification up here. If this is a rubber band, actually this densification increases a lot of tension over the rubber of the lower limb, and if you pull in this direction the cable, tell me the reaction in the middle. The reaction is going to be something similar to this. And that is going to change completely the tension on the organs. Okay, that are going to be pulled out, that are going to be pulled and restricted in the wrong way. Even if they are still fine, there's no cancer, there's no Crohn's disease, there's no disease in the organs, they are just restricted from the outside by the fascia. They are not able to perform their function. Okay? And that's why probably also something like an heart attack can radiate the pain into the upper limb. Because, for example, from the heart, the pericardium is attached to the arch of the aorta, and the aorta sends a fascial septum that goes directly into the medial intermuscular septa of the heart. So every time actually the heart is kind of like cramping, it pulls this connection and radiates the pain exactly like a sciatica into the heart. That's why actually the kidneys can create pain anteriorly, because the fascia of the liver, of the kidneys, is sitting down, so it's connected directly to the fascia of the psoas. So the kidneys actually are pulling the psoas. That's why actually a lot of girls are suffering from menstruation, back pain, or knee pain during the cycle. So just by acting from the distance, you can also improve the function of the viscera. And this doesn't mean that if there's a real disease of the viscera, you're gonna improve it. If actually there's a disease, there's nothing you can do. But if it's a wrong function due to the tension that they receive from the fascia, there is where you want to act, and that is where you can get good results. So you're gonna understand how the autonomic system can regulate the viscera. You can understand how the fascia can regulate the receptors and the ganglia of the autonomic system in order to coordinate several organs together. You're gonna be introduced to the concept of an organ fascial unit, so the catenaries, and it's a total new concept, it's a total new way to combine the points that you already know. So instead of thinking in terms of lines, in terms of sequences, in terms of spirals, in terms of force transfer, you're going to think in terms of better opening. You're going to be introduced to the concept of tensile structure, and you're going to be introduced to the concept of distal tensors. And that's it. This is how actually we can, exactly like the acupuncturist, we can treat and we can improve some visceral issues. So you're welcome to come at the third level, which is going to be actually once a year here in Tel Aviv, in the same room where we are right now.